foundations, we discussed the pipeline like EL, ETL, and ELT. That those are like common setups. So that was, I think, data engineering, data flow. Okay. I think this is the one that we discussed, that we have like EL and ETL and ELT. So after this, what else we discussed? I think we conclude that the skills and all also, and then we concluded that the skills and all that this is some feed, and then we, I think, started the S3 also. So one said that this is something new, so it will take some time, but we let me share again. Screen is being shared. Yeah, this is a bucket that we created, and then we in the standard we did some activity like uploading, downloading the files and folders. So these were the commands. So we also said that this is all 3-4 commands that we use, but there are like uh, remove, make bucket, move. There's like 3-4 more commands. If you are interested, you can also explore via documentation. But these are like CP and sync and ls. These command works in most of the cases. This is one service which is very, very important. Action is unstable. Just give me 1 minute. I'm coming back. And now I hope to say better. So CP, sync, and ls. These are the commands that we said. So I was explaining like S3 is one of the important service that we should like understand and know, because it enables us to share. Store the data, large amount of data in cloud. So that is something, and you will find whatever service you are using in cloud, in Google Cloud also. There is a GCS bucket, Google Cloud Storage. So it is very similar, and the command and structure is also, and the overall concept is almost same. And then in Azure, it's a blob storage. So blob storage is also very similar in nature. So the purpose of this is to store the objects. So you can store any kind of data, structured, unstructured, or semi-structured in this bucket. So that is something which we should know. Then this is something, let me show you RDS also. This is another service which we use to create databases on cloud. So as you know that during our we have covered some SQL and all databases also we were doing. So that also will include in our context. So in our SQL, you know that it started with like basic, intermediate, advanced, and before that I actually explained you like how I like ingest the data into the cloud or the database. So if I again open that one to give you better context, for example, this select statement. So remember, like we used the Jupyter notebook and we were running our queries like this, right? So this is something like how we are telling the environment that we are running the query and this table, like where this is stored. So that part we are trying to understand now. So what is happening? I first downloaded the CSVs here, and that listing like I showed you yesterday that when I listed this, there were a couple of CSV data files which are available. So those files I ingested into database. So what I did, you can see here that I think Python code, you should be aware of most of that, but let me explain the remaining. So basically, I think you know that SQL alchemy is for database. Then in our Python advanced, we covered this scenario also that if we have to work with databases, so that was one scenario which we covered in Python advanced that I explained you the code of how the code looks in Python when we work with databases. So there we cover this SQL Alchemy package, and the new package this time is this MySQL.connector, and this help us to connect to MySQL database. Similarly, in Postgres is another database just like MySQL, and they both are relational databases where we store the data in table formats. So to connect to Postgres, we use PsychoPG2 library, and for MySQL, we use this library. And this code piece, you are aware that what we are doing is we have our credentials stored on cloud using the secret manager service, and we are pulling that credentials now here. And those credentials we are using to connect to our database in cloud. And that database, now what we are doing, once we have the connection ready, we are actually started to load the data from CSV files. So if I use the pandas to read the CSV, you can see that, for example, this particular file, which is in CSV, I'm loading into pandas data frame, and it looks like there is like 559 rows and 7 columns total. So this is a data set that I have, data frame. And what I'm doing now, I think this also I explained earlier, but let me revise. So what I'm doing, whenever we need to ingest some data or CSV file, any kind of file into database, you need to create the schema. So in the database, we need to tell that what are the column names and also table name, and then in column names what are the column types. So that is called a schema, like table name, and inside table name what are the column names and their types. So what we do, we generally write a statement create table, but pandas also can help us to generate the that kind of statements automatically. So that is something we are using here, that pandas feature. So what we are doing, we are loading our data frame from this file, CSV file, and there is a utility in this particular module, IO SQL get schema. Here we are providing data frame. Then also we are saying what is the table name that we want to mention in our database. So we are saying in our database, we want to mention this particular table, US housing units. And then the third parameter is connection object. So connection object here is doing like it depends on the database, the kind of a schema differs. For example, this schema is specific to MySQL because I'm passing a MySQL connection object. But if I pass Postgres connection object, the schema of create table will be different because Postgres follow some different patterns when they mention this particular data types. But pandas handle that automatically, and depends on our connection object, they automatically generate the schema. So then all I need to do to create my table, which is blank table I'm creating, is copy this and execute. Now to execute, I'm directly executing in my Jupyter notebook, because this particular extension also we covered that I told you that it enable me to run my SQL queries directly via Jupyter notebook. So that is also one feature of Jupyter notebooks, that we can connect to any database and execute our SQL here. And this is called magic commands. So in SQL, you will find magic commands. For example, %SQL is one, then %write file is another for writing the anything into a file. So that is also like some magic commands available. This one is SQL one, and you can see that this is like output. This confirms that there is no error. That means our table is created. But because we haven't retrieved anything, so it is showing there is no rows, so nothing is affected. But it is just a way to tell us if some information is back. Otherwise, our table is created there. So once we create the table, then we use this kind of statement. It's a utility which is like a command which we run in terminal. So here we are actually running it like compress local username, password, all the details you're providing, and also we are telling that the first line of our CSV is kind of a header, which is like column name. So ignore that. So from the second onward, that will be data that we need to ingest. And that is in this format. Like the first value will be year, second is month, and last will be northeast, which is a float. So that is something also the path. So this is a path. And once we run it, our data gets ingested into the database. That is the process that we follow, and the same process I followed for all the tables that we practiced during SQL. So that is the way to ingest the data. Now, also, what I'm going to show now is how to create this kind of data. So let's go to our AWS. Let me log in. Just a moment. Because the database is on cloud, earlier when cloud was not there and these facilities were not available, people used to like install it on local servers and then connect to local servers. But now cloud is like providing these facilities to us, and we use cloud for our databases. So as a data engineers, we should know about these, like how to create databases, how to connect to it, ingest data, all those processes. Just a moment. Yeah, I think it is loading. So that service is called RDS, Relational Database Service. So they actually provide multiple 4, 5, 6 different types of databases. Oracle also they have, but generally MySQL and Postgres are very common. And I will show you both, like MySQL and RDS. So AWS is, yeah, this one RDS. Here also you can search for that service, RDS service. We can also like bookmark in this way. So I bookmark some other services there. This is like RDS here. This is opening, taking some time. I guess it is taking a long time. I cannot sustain this long time. We check so if I have some other networks I can arrange. No, I can't. Okay, so this one is like a home page, we call it. Every service has a home page. In S3 also we saw that we have some kind of home page. So you can see that Amazon RDS. So it's like their RDS service, and it tells us. I mean, they generally have dashboard in most of the services, so it actually explains all the scenarios that is going on. So we have to go to databases like this, and inside that we can create our database. So you can see that in my case these two databases are running. So one is MySQL and one is Postgres. So these two I typically use, and these are good. Like either also we can use either, but I prefer like using both. Then what we need to do to create a new database, in your case when you create your account nothing will be here. So click on this create database, and it will ask you to fill one form, and that form will like ask you some details. So once we create that, it will automatically create your database, and then we need to apply some more settings to connect to that database. So there are two settings, one we can change here, and then other one we need to change from security group. So I will explain that also, like what changes we need there, because without that we cannot connect to the database from our local system. Generally, we need to use EC2 machine for that, connect to database. Otherwise, yeah. So I mean, mark this like a standard create, and if in your case there's an easy create, just say standard one. And then these are like engines that they provide, and you can try other also. For example, in some of my project, I used Microsoft SQL Server, and then Oracle. I use I think only one or two time. Then Aurora is also I like, but it is very costly. Like it is not free, and you will get huge bill if you use Aurora. But still, it is like a good engine that is available. Then MariaDB also I think I used once, but never used otherwise in any project wise, just for learning. But MySQL and Postgres are like very, very common. So you will often see in most of the project that they use like Postgres, MySQL, and just select any of that, whichever you prefer. You can choose any. I mean, both are equal, I would say. And then once you select that, then they will ask you version. So just you can make it like default, or you can also select the latest one if available. For example, it's like 31 is there, so default is fine. And then in template, select the free tier. Free tier is more than enough for all kind of basic work, and even dev test is not required. It's like when multiple people or teams are working, only then they use this kind of system. Otherwise, for single user, this free tier is more than enough. Then you can name it anything here. By default, it is like a series database 123, and you can name it anything. Then remember this username. Again, you can mention anything based on the requirement, or this kind of their restriction. In this limits, you can like name anything, but you have to remember it, because this will be used to connect to database. This is like one of the important string, which is called username in our connection string. And then also remember the password. Just set the password and remember it. So, and then leave it to default T3 micro instance. Then here you don't need, I think, a 200 GB of that to start with. So just make it to 20. 20 is fine. Then also disable auto scaling because it will otherwise cost you money. And from here, yeah, don't connect to EC2. Everything is default here. You will even get default VPC. And here, make sure you enable the public access because otherwise you will not be able to connect to your RDS service. Then VPC default, everything is default. Then password authentication default, everything is default. We just need to, if you want and you are okay with that, I mean, that kind of even higher, you can also explore additional configuration if you need. So that kind of thing you can do. So otherwise you can leave it blank. Otherwise also you can like get some logs and all that. So that is all. Like you just need to change something here and there. For example, one change that we mentioned is public access. Another one we mentioned is space change. Then username, password, and then create here. These are the 4 changes. Then create the database. It will like take some time, and then create the database for you. Once you have database, you can go there. For example, this is MySQL one. If I go there, you can see some like default metrics and all that information. So I'm showing you like how to get the host name. So we have username, password, and one more thing we need is host name. So once the database is available, you will see that the endpoint is our, these are the important you would say values which we need to connect. So after that you will be able to connect. And port is by default is this for MySQL 3306. So you can mention that also. But in most of the cases, even they do not ask you about the port because they know that default is this one. Then one change is the public access enablement. Another change also you need to make via the security group. So I think security group actually in my system in this Chrome, it takes a lot of time. Not sure why it every, so I need to use maybe in some other browser like Safari, I need to open it. So, but otherwise here also you have to make one change where we will open the our security group inbound rules. We will add, and that is like security group concept is like it's kind of a I mean kind of a group where, as the name suggests, like it decide like what is the inbound and outbound traffic. So it actually decide that what traffic is allowed. So you can mention even IP address that okay, I only the traffic incoming traffic from this particular IP is allowed. So that is like control that we like do. So in inbound rule, you can mention that okay, I am only like access from this particular IP or a set of IPs. But in our case, you can either mention if you are concerned about security or you want to practice that kind of thing, that you can say your IP, if it is fixed, you can mention that also, and that will work. Otherwise, you can say general, like inbound rule open to all. So that way is also okay for us. Here, actually, it will and you have to and then open that. In some situation, if you are like practicing it and you're facing difficulty, let me know. We will jump in and resolve there. So this is like the settings that we need to make, and that's it. Like it is that easy. After just filling out one form, and your database is ready for all kind of services that we need. So it is like set for cloud is like that way. So this one is RDS, and other components actually of this we already covered in SQL. Like I showed you how to just now ingest the data, the process of that, and the how to create the database in RDS, and the similar way work in Postgres also. The same process For example, the port number is different. Otherwise, the process is exactly same. Here you can see in Postgres, the port number is 5432 instead of 3306. So that is, I think, the only major difference. Otherwise, the process is almost same to connect to Postgres also. And yeah, that's it. Like RDS is all about this to work with databases. So if in future somebody asks you, can you create database? So now you should be able to create database and also like connect to it. And if somebody asks you to ingest the data into database, so you should be able to do that also and practice that, like get some create database here and make the changes. One change is public accessible, another one is security group open bound, inbound rule open, and then once you connect if via your Jupyter notebook, try to ingest something like create some CSV file, ingest it here and query via SQL. That is a like complete cycle that you can do. So that way you can scale it also. You can ingest a large amount of data, query it, and not only us, anybody in the world who have credentials can start consuming instantly from the database. And that is like the whole purpose that we solve our databases, so that anybody can apply operations there, ingest operation, retrieve operation, read, write, those operations. So that is like about RDS. Let me know if you have any question on this. Then Redshift is also a storage layer, just like S3 for object, RDS for databases. Redshift again storage layer that we need, but Redshift is a warehouse. And what the difference between warehouse and database, or in this service way, what is the difference between RDS Postgres, RDS SQL versus Redshift is this is database and this is warehouse. So now comes the question like the difference between database and warehouse, and that would be like databases are for transactional purposes only and warehouses are for analytical purposes. So transactional purposes we call them OLTP, and warehouses are for analytical purposes and we call them OLAP. So these are like two different terms, and interviews they generally ask you these kind of questions also. OLAP, OLTP. If not, definitely you should include this in your explanation, that when somebody asks you about database or warehouse, also include these terms. So OLAP and OLTP. So Redshift is again underlying engine is Postgres. Engine is not different, but so I mean the command that you learn in Postgres also work in Redshift, and even connect to Redshift via Python actually is the same, exactly same, just like Postgres. But the on top of engine, actually Redshift team enable all kind of features that they can for analytical purposes, so that from if the analyst run the query, that same query, if it is complex query, it will take huge number of time, like maybe let's imagine it's a complex query and it could take 5 minutes of time in RDS services, but the same query will just take compared to 5 minutes, it would take 1 minute or less in Redshift. And the reason is that the way data is saved. So the storage layer is in warehouses is columnar. So that we call columnar means data stored column by column. First column, then second column, then third column. So if your query only required to pull 2 columns out of 100 in a table, so that way Redshift can pull just those 2 particular columns and apply operations. But in RDS, because it stores the data in a row by row format, first row, second row, third row, because it is designed such a way, like OLTP is designed such a way that it support transactions like row by row operations. So transaction always works in rows. So therefore RDS and OLTP in general support row by row operations, and therefore they are not optimized for queries, complex queries. You cannot run analytical queries of joins and all that thing in RDS, because they will give you the answer, but they will take huge number of resources and time. So therefore it is not recommended, and definitely people move to warehouses in that case. And the difference is also big data. the Redshift and all, you can store petabytes of data, but in RDS, you cannot store petabyte of data. It is limited to, even in organization, big organizations, they do not have support for storing petabytes of data. They can support, I mean, they store only in gigabytes or terabytes at max. So big data is something which is supposed to be analyzed, not transactional, right? Transactions are like just happen, and we typically build pipelines therefore, so that whatever transactions happen every hour, every day, every week, month, so after regular intervals, or maybe in real time also, people build real time pipelines. And by so that is like EL or ETL pipelines, where the source is their companies, the same company's RDS system, and they have to move the data to warehouse so that analyst team can run queries on. So that's something we also generally do. So definitely RDS is required, but for data engineers, RDS is, I mean, the role of RDS, or I would say in general, database and warehouse are different, and we should be aware about these differences, because companies expect the candidates to know the difference and should work on both the systems. So that if requirement comes, it's not like if you know only warehouse or only database, it will not work. You have to know both, so that you can work in, even for example, if they ask you to create a pipeline, so not only we have to know how to connect to Redshift and how to connect to RDS, but also like how to build the pipeline. So all three knowledge is required. And therefore Redshift is something which is on a warehouse side, OLAP side. So that is otherwise, I mean, query perspective, I would say it is same. You can run the same queries, SQL queries, everything is same otherwise. So if I go to AWS and I search for Redshift, so just like Redshift, uh, we have in Google Cloud, we have BigQuery. So BigQuery is again a service from Google in Google Cloud, just like AWS Cloud provide Redshift. Google Cloud provide BigQuery. So that is like equally competitive solutions. And then there is another one which is also pretty famous, is Snowflake. So these are like three warehousing solutions which are available in the market, and all three are like growing at a rapid pace. And in last few years, they actually grown at a very rapid pace, and currently also they are like moving forward, and more people are moving and using them. So that is something which are like three different solutions, but all are competitive enough to like compare. So Snowflake is a separate one. So that is like on the, I would say, it's not dependent on any cloud. You can use it on any cloud, GCP, AWS, and all. And these are like cloud specific. You have to use AWS account to use Redshift, and similarly applies for BigQuery in Google Cloud. So if I go here, and you have knowledge about one, you can, I mean, you can easily say that, yeah, you know, not only about Redshift, but warehouse in general, because they work on same similar way. So it's like our goal is not to learn the tool only, but to learn about the category. So OLTP, when we say like our goal is not to learn about RDS, but database in general. Similarly, when we are learning about Redshift, our goal is to learn the category like warehouse. So tomorrow someone asks you about warehouses or BigQuery. So they like same concept will be applied. So here, this is a dashboard again for and for Redshift. And if actually the one more interesting thing is that you also get some kind of editor here. So in there in RDS there is editor, but that is, I think, a new feature they are still trying on that. And for Aurora they have, but for Postgres and MySQL they do not have that one available rapidly. So but here actually it comes naturally. When you create a warehouse, you will see that you will get this button, query data. Here you can get a fully fledged editor, and whenever someone or in a team work on Redshift, they generally use this kind of editor to work. So we will get a full editor where you can explore the databases and all that thing and run the SQL queries also. And there's some more features. I will show you like charts and all. We can build charts and then notebooks. So notebooks is not like Jupyter notebook, but kind of SQL notebook where you can arrange your SQL queries. So if the engineer or developer working on tens, hundreds queries, so they can easily arrange in a notebook. That kind of extra features are available, but mainly they are like optimized for working with big data. So it's we can easily like query 10 terabyte data with in a single query. You can analyze that and output by writing SQL. So it is like supported here. And another thing that I noticed about warehouses is like a single source of truth, something like that, which this term is actually very common also. I mean, people use that. So single source of truth means like everybody in the different teams in a company keep putting all their data into warehouses. It's like they just imagine that warehouse is scalable, it can support everything, and they just keep putting all data, whatever they have, into warehouse. So downstream teams start consume. And also, as we discussed that in our foundation, that we have not only ETL, but nowadays ELT is also becoming very common. And ELT means extract and then transform. So extract from some sources and in warehouse, and then inside warehouse we transform the data using SQL. So that is also one common approach where, but as I said that it depends. Like if your data is highly complex, definitely we cannot load into warehouse and transform it there. We need some advanced transformation tools like PySpark to do that. But if you can like easily um, transform the data, then SQL will work. Simple SQL statements or complex SQL you can write to transfer the data. And in that case, it becomes mainly ELT pipeline, which is actually preferred because you do not need to like move the data via clusters of PySpark and Spark and all that thing. Simply load the data into warehouse and transform it there. So most of the companies also started using this one then because their data actually was not complex. They were not using images and all that thing. They were simply using tables, different tables, and those tables they were joining and all using PySpark. But now they moved it into DBT and all the tools that we in our future sessions. So that is like loading the data into warehouse and direct query. So here also, yeah. So it's like this is how it looks. It's editor, and this editor is like a database you'll find here, all the list, and then this your window where you can run your queries, and you can like uh, create different windows just like that. And if you want to create notebooks, you can also, notebook is just like query but in a like a collection of queries also. So that is again a feature that you can use. And then by default actually they put a limit of 100, but you can also change the same way. You will, I mean, the same interface you will find in other warehouses like uh, BigQuery and Snowflake. I mean, on the left, you find database list, and you can even query and write the query for something. Then again, I mean, extra feature I would say, but yeah, you can even build chart and all. So you can add some query that will build something out of that. For example, group by group by country and count how many incidents happened in particular country. So that you can plot as a chart. That all thing also we can directly show here in a chart. That is also like all this thing comes, but generally and the purpose is like database very on a large scale. So that is something said, but yeah, this is all about the warehouse. And if I explain it a little bit more, is like in private there is concepts because earlier what we need to start a cluster and the cluster was very costly. So and but the serverless service is not actually is good because let me share. Yeah. So in I think screen is you are not cannot see just a moment. It is saying loading. Yeah, let me explain. So serverless, there is no server that we need to create, but we can just I mean focus on our work. So that is like a feature because without serverless, we are not paying for the server now. Earlier, what happened? If I give you my example, I need to actually create a server first, and that server is super costly. So even for 1 hour, I need to think a lot hard because it will like cost me money. But in serverless, what is happening? I do not pay for the server. I need to just pay for the query that I use. So if my query taking 5 minutes, I have to just pay for those 5 minutes and not like if I run my server for an hour, I need to pay for full 1 hour, right? Whether I'm running the query or not. But in serverless, the server concept is gone. Like I there is no server that I need to manage. I just pay for the usage now, whatever usage I have. So it's better compared to the serverless. I can even scale. And another feature is scalability because not only saving the money because I'm paying for the required cost only, but also scalability because in my cluster, I need to just decide a fixed capacity that I can use and need to select during the cluster creation, just like you were selecting in our databases, right? But in serverless, there is no limit of that. You can scale up your query and allocate more resources during runtime. That is also possible. So these are like two advantages that is we can use in serverless. So make sure in interviews you explain all that because not who can explain on the regular things. They want someone who knows about the different things and can compare. So you have to compare there, explain them like why serverless is better and why we should use that compared to the other one, something like that. So this is warehouse, and then there is another service called Glue. So Glue is again kind of a ETL tool, I would say. ETL tool is like, as the name suggests, I think they might have used it because of that only. Like Glue means like combination, combining multiple things together. So it's kind of ETL tool. I will show you actually. Glue is like a super big picture where I mean it include three, four, five very good tools because I would say it is one of the essential tools for data engineers, and it include like four, five different services together in a single service called Glue. But imagine it like a collection of services, like a three, four, five different services. One by one, I will explain all those services, and I think because they are like connected, so therefore they named in a single service. But still, I mean, if we understand them separately and then combine, then it will be better. So don't confuse, like Glue is a single service and there are a lot of features, but consider them as a separate service, what I'm going to explain. So if I name them until it is opening is like crawler, AWS Glue crawler. Crawler is something which help you to like understand the data for you. So if you put some data in your S3 bucket, crawler can go to that particular location in your S3 and understand the data and then create the schema automatically. So just like in our local system, we're using pandas to the data and generate the schema by using that facility. But here, crawler is doing that work for you. So even if your data is like terabyte, you don't need to download it or use some tab or any server like that. Crawler is doing that for you. So On the left, you see that crawler service. Here, we create one crawler, and that crawler uh, goes to your S3 bucket, and from there it pulls the information, which is called metadata. Metadata means like the same thing, like column names and table name and column types. And that might not be 100% accurate. Therefore, in some cases, you can even change the schema. That facility is available to us, so we can decide that. Otherwise, crawler is just a helping tool, utility that we can use. Otherwise, if you want to directly create the table, that is also we can do. But crawler is something which generally helps, and whenever your data changes, even then you can schedule the crawlers. So I will show you one crawler maybe. Yeah, I think the description also like explain all that thing in a single line. So just remember that crawler is kind of the service which help us to identify and understand our data and then create the metadata out of it. Otherwise, what you have to do, you have to manually do all that activity if you use crawler, right? So that is something which crawler actually help us. And you can see a couple of crawlers we have. So something similar we can create like by creating crawler here and then mentioning all that things. So all we need to do is like tell them about the source and destination. So where in S3 we need to go and what is the target. So target is like what is the database. So now that comes the target part, like where the metadata will be stored. So what happens once you create a crawler, then you click on it like this and run. Once the crawler finish, for example, if I open this one, so let me move this one side. So three primary service I would say which we are using is crawler and database tables. Database and tables like is similar to those RDS, Postgres, and Redshift tables. Again, it's something similar. You can use it as a warehouse also, like a large collection of just like Redshift. So what is happening is now a different architecture. So first of all, it's a total serverless. There is no server we have to maintain. It's simply services that we need to pay for usage cost. Then it's a I would say different architecture because it's not a regular warehouse. It's more of a you know lake house. So read about it, like what is the difference between a warehouse and a lake house. So you will understand like what different it is like, because the reason we are calling it lake houses is a like a combination of data lake and warehouse. So if you combine those two terms together, it becomes a lake house. Data lake and warehouse, lake house. The reason we are saying it is together is in our foundation, you might have noticed that we have one chart. If I open the chart, yeah, so you notice that we were saying from the source, we extract the data, store in data lake, and keep transforming it. And once it is ready, we load into warehouse so that analyst team can query. Now there is a new technology or some new concepts are emerging. Why can we skip this part, this loading into warehouse? Because that looks like additional part. If analyst team, if we add some support directly here where the actual data is, because this movement cost is also time consuming, like we need to move every day, every hour, every month, week, lot of data from one place to another, and that creating a copy. We cannot delete the data, this data, because we need to store that also, and that is like creating some copies and all that. So a lot of reasons are there. One is like obviously cost of transfer and cost of storage, and then warehouses are anyway very costly. That is another reason from the cost perspective. transfer cost, storage cost, maintenance cost, and that time, like takes time because you to, I mean, this process is additional steps. So people are saying like, can we do something where we enable the SQL facility directly in the data lake, so that wherever the data is stored, can we query our data directly there? I mean, without moving the data, can we run the query, and at the runtime, some kind of engine bring the data, required data from the S3 only? Can we do that? And that is a technology we call lake house, because this is a lake and a house, so it's like combination of that is lake house. So that step is like this particular uh, module is not there. It's like simple, everything is happening here, and also the file data also we store here. So the glue and S3 and one more thing I will tell you. So all those actually are part of that house. So what is happening? Yeah, so you can see that this crawler ran and shows us cost. So it's like DPU our unit is specific to, I would say, the glue unit, but I think there is some mapping of like for one DPU, what is the total cost, and this is only usage cost that we need to pay, nothing else. So once we have our crawler completed, they mention how many tables changed, partition changed. So we can see that 3 tables are changed or added. So in this case, they just mention change. So that means like 3 tables are updated or added. So that was like from the source. So this is a source. You can see that the particular path. This is the source where the go and understand stop. So this is the path where the, I think, let me wait. It is showing screen is loading. So the source and crawler go here, and this is the destination database. So this database, which I talked you about, Lakehouse and all that, it is of that kind. Like database are we are creating here, but data is not getting moved. Data will still be here, not moving the data. We are just understanding the data, and once we understand it, that is called metadata, because we know that what is a table name, what is a column name, what is a column type, and that is all we need. So data will always be here. We are not moving the data at all. But the metadata we are storing into database and tables. So I'm saying in this database, just whatever you grab from here, table name and all, store in this kind of database. We can name it anything, and we can create any amount of database. It's totally free, nothing to pay and nothing to, even it do not take much time. Within a second, you can create database. So I've created database and don't need to pay anything. It's like database there in any other databases. There also we can create any amount of database, right? Just like that. But no data here. Data is in as 3 buckets. So that data I will show you what we identified the data lake. I think it will take time. I will arrange a better network also for next session. But this is like once we have database, we'll explore this part. Then, so then I will also tell you one more part which actually enable us that kind of thing which we want, like query database. So that query engine actually will come in Athena. So tomorrow we'll also cover Athena. We'll start from databases and we'll also cover Athena. So that actually is a lakehouse format, which also is very important. So make sure this concept, guys, if you're not sure, but explain in interview, and because this is all important. So lakehouse is also very like recent and emerging term. and people are start using in production also. So this will give you enhanced benefit when you in competition. So this is databases here also here opening. Okay, yeah, this is like database AWS Glue, and I think these are 4 services we mentioned here, but I think I can show some more like will it is okay. We check in curriculum. So these were the services. So Athena, yeah, Athena, we mentioned that we will also cover that. And then DViewer. DViewer actually is a tool which we install in our PC. So I will show you that tool. That tool is like help us to connect to different databases. So I will also show you that tool and how to install it. And then we'll also connect to databases, MySQL, Postgres, and Redshift. And then we also query some databases there. So that is something we'll do, and that will like our tool that we want. So these are like only tools, but a lot of other tools are there, but something very common which we use are these. And then we'll I think this advanced Python we anyway covered. After that we start the PySpark. Let me know PySpark. Actually, as I said, it depends, because first you should be comfortable on SQL and Python. Only then move to PySpark, because in interview there is no advantage. They will prefer Python, and only if they think that you know Python, only then they will ask you question on PySpark. Otherwise, they will not even prefer if you do not know Python to like a very comfortable level. So make sure instead of PySpark, first like focus on Python a lot and SQL, and then if you're comfortable, let me know. Otherwise, we are anyway start with PySpark after these tools, and if you are not comfortable, then we will maybe revise Python and SQL instead of PySpark. And then Scala, again the same situation. PySpark, Scala like should come Python plus SQL, and yeah, that is the one that we cover next. Okay, yeah, I think that's it. Today, Tahir is not here. Priyansh is okay.
Priyansh,
Yes.
can you share the recording link to there, like so that you can send me?
Okay, I will share the recording.
And I didn't get the yesterday link too. Can you send it to there?
Okay, sure, Pawan.
Yeah, thank you.
Thank you. Thank you, Pawan, Priyansh. We
Thank
will
you.
meet tomorrow then. Thank you.
Thank you, Sparsh.
Thank you.